Of this video is to make sure you know how to organize your mixing different velocities notebook. I'm not going to show you all of the data. I have done the lab, but I just give you an idea to make sure you get started correctly. Really, you should always title your lab, and you should always put any equations. I will put them on here to help you realize those are the only two equations we need for this lab. So you have your data table. We take our Doom Buggy video time and our fan cart video time off the graphic analysis video. You notice they will start the same time because I release the fan cart when the Doom Buggy's next to it. But after that, for the most part, these numbers are going to be different. So I get these two from video physics. I calculate this one, as I show down here, by subtracting my starting time, and I do the same thing for the fan cart. So I now have both my fan cart and my Doom Buggy time starting at 0. And I didn't show all of that, but you know how to do that with your TI, with your list. Everybody's going to have the same time because the same position, because we all have the same course. The first thing before we calculated, if you follow the order of the instructions, we are supposed to graph the position of the Doom Buggy versus time, and you need to do that with your TI because we need to just put in the points. Remember, my time will be my X value, so I have two scatter plots, one with this time for my X with this distance, that will be my Doom Buggy, and another with my fan cart and this position. So I'll have two different scatter plots. Then this is what I mean when I say to sketch a graph. I'll raise this a little bit so we can see it better. All I expect to see is you should have the same window you used on your TI. Just use your window values. And probably be nicer if you picked your own instead of letting the calculator pick something with 10 decimal places. But whatever you use, you could round it. If the calculator used 5.9867, you can round it to 6. But this is the actual window I used, 0 to 6, and my position value went from 0 to 2.5. So I expect to see my 0 here on your graph, on your sketch, and this value, so I know your window. These lines do not match my data. I want you to find out for yourself what the graphs are going to look like. So I'm going to have two graphs on the same grid. Now you will show me on your TI, so I'll see it, but I want it sketched on here. And the only points I want fairly accurate, or I'd like to have the beginning point accurate, and the end point, and where they cross. Make that reasonably accurate. You don't have to label all this, but it should be close. Then your instructions are going to tell you to mark where they have the same position. Where lines have the same position is where they cross. And if you need help doing that, there's a quick, short little video on how to use your TI to find that. Then I will write my equations down, and again, this is just to let you know when you look at your notebook, the lines are fake. They're just to illustrate how to do a sketch, and what I mean when I say to mark where the position's the same. That's going to be where the lines cross is where the positions are the same, and then this exact same line I put on my velocity graph. Okay? So I find my position where they're the same on this graph, and I put it over here. Then on my velocity graph, and you notice I find where the positions are the same, and then I put that on my position graph. Now that's only going to work if you have the same window, and when you graph these, you should use the same window for your x's because that's not going to change. Okay? Your time, use the same window for both of them for your time. Now this value up here may change. Your velocity you may use a different window up here and label that, and that's fine. But you want your x-axis, which is your time, to be the same. So make sure you allow enough time that they both fit on it. Because it may take one of them will get there first, so use the largest window time. I want the time for this sketch, the time scale for this one and this one to be the same. So you'll need, when you do your graphs, make sure you can do them both with the same time window, the same X window. The way to make sure you can have the same time window, the same X value for both of your sketches, is look at your time here. One of these is going to be bigger, probably the dune buggy time. Pick your biggest time, go ahead and set your window manually. I'll show you how to do that real quick. So when I'm on, have my calculator on, all you have to do, I'm going to lower this back down so you can see. Just hit the window button and then set the time. Set the time. So your X value, set this to round, I'd set it to a round number bigger, just slightly bigger than the dune buggy time, because the dune buggy should take longer to get to the end. Your Y values can be different on each graph, but I want my X min to X max to be the same for both graphs. It doesn't have to be 6, your values may be different, but they have to be the same for both graphs.